Hey there, Chem Scholars. I'm going to follow up on Friday's little lesson about naming ionic compounds with a special set of compounds. Okay. So I'm showing you from the packet right here. We're talking about acids. And as you look at the acids, what stands out there to you? Okay, so we're looking at compounds that start with hydrogen. Okay. Now, to be honest, to be an acid, there's more going on than that. Okay, so technically there are two names that we could give these things. Okay, it could literally be treated like an ionic compound and be called hydrogen chloride, hydrogen cyanide, hydrogen nitride. But we're not going to do that at all. Okay, whenever we see it like this, we're going to assume it's an acid. Okay, and so we're going to talk about the naming scheme of acids today. Now, because they all start with hydrogen, the name focuses on the anion. Okay, so that's really huge here. Okay, keep that in mind. So let's look at anions again. Okay, notice that anions all end in either ATE, ITE, or IDE. Okay, and that even includes the monatomic ions, right? Like chloride, bromide, sulfide, phosphide, nitride. Okay, monatomic anions end in "ide". Polyatomics mostly end with "ate" and "ite", and we have two "ides". Well, really, it's just this one because hydroxide is not really going to make an acid, but we'll get into that at another point. All right, so the way that we name an acid depends on this suffix, okay? Whether the name of the anion ends with "ate" or "ite" or "ide". Okay, so that's all it's going to come down to. I'm going to shift views here and let's talk about it on the board here for a moment. All right, so as I was saying, it goes by the name of the anion is going to determine the name of the acid. Okay, so for example, if it ends with "ide", like chloride, then the acid will be hydrochloric acid. We take the root from here, drop the "ide", and insert that root into here. Okay, so for example, HCl, okay, we ignore the H. Cl is called chloride. Chloride becomes hydrochloric acid. So this is hydrochloric acid. Okay. Now, what if it ends with an "ite" ending? And we're going to do the same thing, but we just stick the ending "us" on. So, for example, HClO2. Okay, that is called H obviously is hydrogen, but the ClO2 ion is called chlorite. I get rid of the "ite", so chlorite becomes chlorous acid. We just pop that ending right onto it, right there. Okay, and then if it's an "ate", okay, we make it rutic acid. So, for example, HClO3. ClO3 is called chlorate. Chlorate, well, then that means this is chloric acid. Now, I know it's confusing a little bit because this has an "ic" and this has an "ic". I didn't make up this system myself, okay? But I can tell you that whenever it's a hydro, there is no oxygen in it, okay? So if it has oxygen in it, it can't be a hydro. Cannot, okay? Now, here's another one that gets people confused, okay? Because let's talk about this ion real quick. HClO, okay? ClO is called hypochlorous acid. Now, I didn't just put that hypo on there. That hypo is part of the name of this. So hypochlorite becomes hypochlorous acid. Okay. Again, it's the same idea because this is a hypochlorite. I just get rid of the root and I take the hypochlor and stick it here, hypochlorous acid. Okay. So I'm going to go through examples with you from the practice packet and leave you to try a few on your own. All right, so let's switch back to that real quick. If I can remember where I went. Yeah, that's where I want to be. All right. Okay, so it might help you to look at your ion table. I know that you're working hard to try and remember them. Okay, but let's go through this. Okay, so we have HI. I'm going to ignore the H, focus on the I. I is called iodide. Okay, so that's that IDE ending that we talked about here. So that means that this would be called hydroxide. iodic acid. Okay, I took the iodide, I dropped off the ide, and I stuck it right into the middle of that hydroic. Okay, so that's where that's coming from. Okay, the iode is from iodide. All right, this one we just talked about, but I'll go through it again as if we didn't. Okay, so ClO3 is called chlorate, and that's right here. 8 becomes ic. So this is just chloric acid. And I really did mean to go boom, boom. All right. BRO, we're focusing on here. That is called hypobromite. Okay, so ite becomes us. So I just take the rest of that name and say it's hypobromous acid. And once again, I thought I did the bold underline, but who knows? Okay. All right. CN is called cyanide. Okay. Notice there's no oxygens in this. Okay. This is cyanide. Ide means that we're talking about hydroic acid. So this is hydrocyanic acid. All right. Pause the video. Try a few of these. I'm going to go on. All right, MnO4 is called permanganate. 8 becomes ic. So don't worry about the per part. It's just part of the name. So permanganate becomes permanganic acid. Now NO2 is called nitrite. And ite becomes us. So this is nitrous acid. All right. PO4 is called phosphate. 8 becomes ic, so this is called phosphoric acid. However, okay, just warning you, it's perfectly fine. You tell me phosphoric acid, we're good to go, okay? However, a lot of people with sulfur-based compounds and phosphorus-based compounds, for some reason, they like that sound in the middle. So this is often called phosphoric acid. Okay, so if you hear me say phosphoric acid, it's phosphoric acid. It's the same thing. It's just the thing that's commonly done. CO3 is called carbonate. 8 becomes ic, so that is carbonic acid. S is called sulfide. The S anion is sulfide. Ide becomes hydroic. So this is hydrosulfic acid. But you may remember a moment ago I said a lot of people with phosphorus and sulfur like that sound. So more commonly people will call this hydrosulfuric acid. Okay. And again, I'm not going to take off if you do it the other way, but I want you to be familiar with these things in case you hear me and you see it in print other ways. And finally, we have ASO3, which is arsenite. Okay, arsenite becomes arsenous acid. All right, so there's the naming of the acid part. Now we have to talk about the reverse scenario. If I give you the formula, if I give you the name, figuring out the formula. So we're really just using the chart and working the other way around, but we have to remember to add on the hydrogens. I can't tell you how many people get confused by that, but we'll go into it, okay? So hydrofluoric, okay. So when I know hydro, I know the anion's name should end with ide. So I'm talking about a fluoride ion. Well, fluoride is F, and it's a -1 ion. Well, since it's -1 and hydrogen ions are +1, I'm going to need one hydrogen to balance out the fluoride, so it's HF. That's it. Hydrofluoric acid. Boom. Okay. Here we see iodous. Okay. Iodous acid means that we have to have an anion ending in ite, so it must be iodite. Okay. I know my ions. Iodite is IO2 and it's also a -1 ion. Well, if it's -1, that means I need a hydrogen in front, so it's HiO2. Okay, so now dichromic acid, we have an ic. Notice there's no hydro, this is just dichromic. Ic means that we must be talking about an 8. We're talking about the dichromate ion. Okay, well, the dichromate ion is Cr2O7, and it's a 2- ion. All right, now since this is 2-, that means I'm going to need 2 hydrogens on this one to balance out the charge. So H2CrO2. So notice, we're still treating these like ionic compounds, but it's just a special naming system because of the fact that they're acids, that they're behaving in a totally different way, and I know we're not ready for that yet. Okay, so here we have another hydro. So I go to the root in the middle, so nitric, so nitra is the root. So whenever it's a hydro, that means we're talking about an ide. I'm talking about nitride. Okay, well, nitride is just N, and it's 3-. So that means I need 3 hydrogens on the front of that to balance out the charge. All right, so now pause the video, give these last couple a try. I'm going to keep going. Okay, so oxalic acid. So we're talking about an oxalate ion. All right, so oxalate is C2O4, and it's 2-. Well, if it's 2-, that means I need 2 hydrogens in front to balance the charge. Phosphorus means I'm talking about a phosphite ion. Phosphite is a PO3. Oops, I kind of need that to go like that. And that's a 3- ion. So that means that I must need 3 hydrogens to go in front. Oops, let's undo that. 3 hydrogens to go in front. Okay? Remember, hydrogens are +1, so it's just a matter if it's a -3, I need 3 hydrogens. -2, I need 2 hydrogens. -1, I need 1 hydrogen. It's that simple. Hydro, all right. Hydro, I know I'm talking about an ide, so it must be a selenide ion. All right, so selenide, selenium is Se, selenide is in the same family as sulfur and oxygen, so that means it's a -2 ion, which means I need 2 hydrogens out in front there. And finally, hypochlorous acid. I actually talked about this one as an example already. Okay, don't look at that and say it's hydro, right? It's not hydro, it's hypochlorous. That's what we're focusing on, is the us. So us means we're talking about an ice. We're talking about a hypochlorite ion. All right, well, hypochlorite is ClO, and it's a -1 ion. So I'm just sticking 1 hydrogen on front, and that's it. All right, that's naming of acids. Okay, short lesson today since I'm currently indisposed as far as this part. I'm sorry. There's also another part of the video you're going to watch relating to finding molar mass of ionic compounds and finding percent compositions. Okay, so you're going to watch another part of a different video I had already prepared just in case. So, yeah, don't know why I'm rambling. By the way, hope everyone's well. Take it easy, guys. Bye-bye.